Energy level diagrams for molecular orbitals. There are two energy level diagrams for molecular orbitals, homonuclear diatomic molecules. In first case, for lithium 2, nitrogen. These are the atomic orbitals, and these boxes represents the molecular orbitals. These are lower energy molecular orbitals, and it is and bonding molecular orbital, and this star represents the anti-bonding molecular orbital. In case of lithium 2 nitrogen, the pi 2p orbital has lower energy than sigma 2p z orbital in case of lithium through to nitrogen. But in case of oxygen to fluorine, sigma 2pz orbital has lower energy than pi 2p orbital. What is the reason for this? 2s and 2p orbitals have small energy difference in case of lithium 2 nitrogen. There is small energy difference in case of lithium 2 nitrogen. This energy difference is small. Due to small energy difference, the electron repulsions means repulsive forces dominates over the attractive forces, and these repulsive forces raise the energy of the sigma 2pz and makes the sigma 2pz above pi 2p orbital. That's why pi 2p orbital has lower energy than sigma 2pz orbital. But in case of oxygen to fluorine, this energy difference is large. 2s to 2p energy difference is large. Due to large energy difference, attractive forces dominates over the repulsive forces, and hence sigma 2pz has lower energy than pi 2p orbital, and it lies below the pi 2p orbital. This is the reason for energy level diagram for homonuclear diatomic molecules. Different energy level diagrams for lithium to nitrogen, this is one energy level diagram, and for oxygen to fluorine, this is a second energy level diagram. There is only a small difference of sigma 2pz and pi 2p orbitals. In first case, first energy level diagram for lithium to nitrogen, sigma 2pz orbital has higher energy than pi 2p orbital. This is due to the more repulsion than attractive forces, more repulsive forces than attractive forces. But in case of oxygen to fluorine, attractive forces are more than the repulsive forces. That's why the energy of the sigma 2pz is lower than that of the pi 2p. Next is energy level diagram for oxygen molecule. Oxygen having atomic number 8, means it has 8 electrons, and of O2 molecule it is of 16 electrons. It has 16 electrons total. According to energy level diagram, electrons are first filled in the lowest energy level according to the Aufbau's principle. Sigma 1s2, sigma star 1s2. These are the lower energy levels, molecular orbital energy levels. Sigma 2s2, sigma star 2s2. The electrons are filled from lower energy level to the higher energy level. First fill in the lower energy level, then to the next level, then to the higher level. Then sigma 2p Z2, because it is oxygen O2 molecule, pi 2p X2 and pi 2p Y2. Pi star 2p X1 and pi star 2p Y1. This is the electronic configuration of O2 molecule in terms of molecular orbitals. This sigma and pi represents the bonding molecular orbitals, and sigma star and pi star represents the anti-bonding molecular orbitals. Anti-bonding molecular orbitals are always higher energy than the bonding molecular orbitals, which are of lower energy. And this 2s represents the atomic orbitals of two oxygen atoms. We have to fill 16 electrons in the molecular orbitals. First starts from the 1s, then 2s, it is 2s bonding molecular orbital, then 2s star, 2s sigma star 2s 2. This is sigma 2pz2, this is pi 2px2, this is pi 2py2, and these are two 2p atomic orbitals of oxygen. They have 4 electrons each, and these are two anti-bonding molecular orbital electrons, pi 2px1 and pi 2py1. According to this, there are 8 number of bonding molecular orbital electrons, means bonding electrons are 8, that is Nb. Nb represents the bonding electrons, and Na represents the anti-bonding electrons. There are 4 anti-bonding electrons in it. These are the anti-bonding electrons. And from here we can calculate the bond order. Calculate the bond order for oxygen. Bond order, its formula is half Nb bonding electrons minus anti-bonding electrons, which is equal to 1 by 2 8 minus 4, which comes out to be 1 by 2 into 4, and from here we get bond order of oxygen is 2. It means oxygen forms double bond. Bond order predicts the bonds in the molecule. Next, we can calculate the bond order for O2 negative. It means it has one extra electron than the O2 molecule. Here, total number of molecules in total number of electrons in O2 negative is 17. It means the 17th electron goes into this pi 2p pi star 2p x2. Its configuration becomes pi star 2p x2. And number of bonding electrons remain same as in case of oxygen, that is 8, but there is one electron increase in the anti-bonding orbital. Here it becomes 5. And the bond order for O2 negative is 1/2 bonding electrons minus anti-bonding electrons, which comes out to be 3/2, which is equal to 1.5. This is 1.5 in case of O2 negative. And in case of O2 positive, if we take O2 positive here, it means it loses one electron. Oxygen molecule loses its one electron, and here the electron of the O2 positive are 15. And we remove these electrons and also this one electron from the pi star 2py, and the number of bonding electrons remains the same, but the number of anti-bonding electrons decreases by 1. If they are 4, then it becomes 3. And the bond order is 1/2 8 minus 3, which is equal to 5/2, and hence it gives 2.5. Next is for O22 negative. If we take O22 negative molecule, then O22 negative molecule means 2 electrons more than the O2 molecule, and number of electrons in O22 negative is 18. And the bond order and in this case the electrons are moved to the anti-bonding molecular orbital. Here number of bonding electrons remains same, that is 8, but anti-bonding electrons 2, 4, 6, they are 6 in number. And from here we can calculate the bond order for O22 negative. 8 minus 6, that is 2/2, which is equal to 1. It means the bond order of O22 negative is 1. It forms only a single bond. In this way we can calculate the bond orders for O2, O2 negative, O2 positive, and O22 negative. The bond order of oxygen and oxygen ions are O2 positive, which is equal to 2.5, O2 2, O2 negative 1.5, and O2 2 negative, which is equal to 1. This is the bond order of oxygen and O2 ions.